Hello from my side. Glad that so many of you are here reasonably early in the morning. It's my pleasure to kick off this year's edition of the conference with a kind of retrospective. But it's actually not as much of a return to history. I will actually spend most of the time on the more recent evolution of the framework. So we'll start back 15 years ago, but we'll actually end in the very present. So from a personal perspective, of course, this is really a 15-year history. It's even now bordering on 16. I started my own involvement at the very inception of the project, so a long time ago. So like with pretty much every Spring Talk, but in particular this one, it is really a very personal story for me. So, well, let's start where it actually started, right? The origin is literally in that book. This book was published in late 2002. By then Rocks. It actually was then republished by Wiley later on. So called J2E Design and Development by Rod Johnson. Who actually remembers this book? Show your age. It's a while ago, I know. 16 years ago. Don't be shy. So this is the original book. There were actually 3 in that series. One that looked very similar called J2E without EGB. And another one that I'll show in just a moment. This is also the beginning for me personally. I bought that book early December 2002, and I read it. It had probably 600 something, almost 700 pages. I read it over Christmas break. So my Christmas break 2002, Christmas New Year, was actually reading this book, and I really enjoyed what I was reading there. Back then, I was an application architect, but with a strong focus and interest in frameworks. I was already responsible for at least one in-house framework at that time, like everybody. We just were cooking our own frameworks for internal purposes. That was the time to do these things. And then I read that book, and the book was not only guidelines for design and development that weren't even so J2E specific, so the title is a little bit misleading even. But it was in particular coming with a sketch for a framework. So that book actually had a download, the good old times, like you had a download for the book, a zip file basically with a very rough framework that barely worked for what it was meant to do, packaged in a com.interface21 package. These are actually the origins of what we now know as Spring. The framework didn't have a name at that time. It was just an anonymous download, right, coming with a book. So I was already very familiar with the early open source ecosystem of the times. There was Struts, we'll get to that, right? So I already had a kind of vision myself. When I read that book, I figured this could be turned into a proper open source project, like Tomcat and Struts at the Apache Software Foundation. So I used the Rocks feedback forum on the website of the publisher to get in touch with Rod, and I like literally in early January 2003. And I suggested to him, what about taking this rough framework sketch, those few ideas and the rough code that you have as a download, what about taking it up to SourceForge? That was the GitHub of the times, right? SourceForge.net. What about taking it up to SourceForge and turning it into a proper open source project, evolving it as an open source project with proper releases and a community and everything else? So he was saying, well, that's a great idea, but unfortunately, I spent a year writing that book, and I need to get back into consulting and earn some money again. So I'm willing to do this. I'm willing to participate in this as well, but I need an equal commitment from your side, right? So he was basically asking to share the load if we wanted to take this forward. And I didn't really hesitate. So we went forward, and I basically said a glaring, okay, let's do this. And we went forward, and in the very beginning of February 2003, we uploaded the code that was there at the time from the book onto SourceForge, and started a pretty intense development phase that turned into Spring Framework 0.9 in June 2003. So just in a few months' time, still very originated in that book, a com.interface 21 download, that was the 0.9 release. It was significantly richer, so in that half year, a lot of stuff started that we still know today, the AOP framework, the factory bean model, quite a bit of stuff, the transaction abstraction, quite a bit of that stuff was actually developed in that first half year of 2003, after the book. And another kind of tradition that started, Spring Framework 0.9 was already the first release that I personally did. So from the very first release onwards, I served as the release manager for the core framework. So I literally uploaded it myself. I did the pre-release checks, I uploaded it to SourceForge, and I did the announcement for 0.9. And essentially for every single release that followed. So in the past 15 years, every single Spring Framework release, even every single maintenance and backport release, I went through my hands in the sense of me signing it off or even me actually publishing it. I'm a bit of a control freak, I guess, but I literally see it as a core responsibility of mine ever since to care for the release management, for release decisions, and for the actual publication. So the 0.9 release, Spring Framework 0.9, was a rather short-lived branch because we turned it into the org.spring framework codebase that we know now just a couple of months later with 1.0 milestones. And with the arrangement, org.spring framework, basically where we're still within now, we went live with that in March 2004. So just about a year later after the creation of the SourceForge project. Remember the times. Back then, of course, this was pre-Java 5. So we were dealing with JDK 1.3, 1.4. It was still a very manual affair in many ways. And XML configuration formats were common. We were in particular focusing on being a good citizen in a servlet environment. And servlets, of course, were configured with web.xml. So in terms of our configuration format, we were trying to align with the common standards of the time. And this was in particular the servlet specification and its web XML format. A couple of other things that were already established, struts, for example, log4j, right? They all had XML configuration formats. So the origins of the framework, the core container itself, already at a time when we saw it as stable and prepared for backwards compatibility, was not aware of any annotations because there were no annotations at the time. So a key design decision that we made back then that is still actually in charge, we're still hanging on to that design decision, is that the core container is unaware of annotations. Nevertheless, there was early annotation support coming at this time already. So in Spring Framework 1.2, already in the one line, this was the beginning of the transactional annotation. Still a bit cumbersome to set up, but it was working. And this was, of course, in the very early days of JDK 5. So nobody was using it because there was no proper IDE support for annotations. Eclipse took a long time to come up with this. And of course, we already had a web framework at the time, but it was sort of strut style, inheritance hierarchy, no annotations there either. At Transactional, it was actually the first annotation that we supported. I was already referring to other open source projects. So just a quick shout out. We, of course, were not the only open source project in the Java space. There was already Tomcat. Tomcat actually wasn't that old at that time. Tomcat was just about a few years old, but it became mainstream. It wasn't just this drop of code somewhere at the Apache Software Foundation. It actually turned into Tomcat 4, Tomcat 3, Tomcat 4, Tomcat 5 then very soon after. Basically very commonly used versions of Tomcat. It established itself as a common choice for servlet containers. Even older than that was Chetty. So this kind of duality, or rivalry between Tomcat and Chetty is actually that old. So Tomcat and Chetty were both around at the time. And of course, a couple of other well-known names. There was already IBM's WebSphere, of course. There was WebLogic, back then from BEA. But we're focusing on open source projects, right? So the other open source project worth mentioning here is Hibernate. Hibernate is about as old as Spring, actually a little bit older, about a year older. And we had Hibernate support, Hibernate integration from the very early days on. We also knew the Hibernate development team pretty well. This is Hibernate pre-JBoss, pre-Red Hat, right? So kind of as an independent open source project run by Gavin King out of Melbourne, Australia. And this is also the beginning of the Eclipse project, the Eclipse Foundation, which is, of course, today the host of quite a few projects, actually including Jetty, which is at Eclipse. Eclipse is also the home of, for example, SPEC-J, the home of the Virgo project that we donated. It's the home of Jakarta EE now, so of the future of the Java EE APIs. And of course, it is the home of the Eclipse IDE, the development environment. So this was just about becoming mainstream back then. These were the early days of the Eclipse IDE. A year later, this is actually the third book in this line. We wrote a book called Java Development with the Spring Framework. I have memories of that book. Basically, as you may imagine, building an open source ecosystem, an open source community, evolving an open source framework, all the engineering time that goes into this, then trying to do a book project is actually a really, really heavy lifting exercise. There were 5 authors in the end. So this is Rod, this is an early version of me. Thomas Risberg, Colin Sampoliano, and Ella Ferenczen to be seen here. So we shared the load among 5. Suffice to say, this was the last book project we were involved in. So none of us 5 here ever wrote a book or participated in a book project afterwards. It was a really cumbersome exercise. I highly recommend books or book projects to go through. If you have the time for it, don't try to do it in parallel with working on an open source project like we did. That doesn't really fly. But the book itself was actually the last one we did, but it was also the beginning of community-written books. There were quite a few book projects about Spring afterwards that we supported in the sense of we helped them a little if they had any clarifications. We wrote forewords, we did that sort of stuff, but we did not actually write a book ourselves anymore. People from the community stood up and wrote books about the then present state of Spring. And this then present state of Spring was actually pretty rich already. Why did we even write that book? Because there was a lot of demand. People knocked on our door. There really needs to be like a proper book about Spring, not just design and development, but an actual book about Spring, the framework. We really need this because in our corporation, everybody's going to have the chance to work with Spring if there is a book that goes with it that we can put onto their desks. So this was really the mainstream phase already. And Spring Framework 2.0, our next major launch, was already pretty interesting in how we got there. We had kind of a target date that we were working towards in October 2006, and we had a counter that was kind of preparing everybody, the community out there, for the actual release day. So it was already a pretty enjoyable kind of release phase. But there was also a lot of work that went into this. Lots of manic development times where a few of us were spending nights in hotel rooms around the conferences back then, trying to get there in time for October. So Spring Framework 2.0 came with what we now know as XML schemas, basically, or now actually commonly replaced with the @enable annotations, convenient configuration features like TX annotation driven. So this originated back then. Just about a year later, we had the 2.5 release, which I find even more important because it had the early versions of @AutoWire, @Qualifier. This stuff is actually more than 10 years old in the meantime. So it originated in 2.5. And not just the core container part of it, it's also the modern day MVC style. So the @controller model with @request mapping annotations actually started back then. in time for the Spring Framework 2.5 release in November 2007. And Spring Framework 2.0 was very much a team effort, the way I remember it at least, whereas Spring Framework 2.5 was essentially me and Mark Fisher working on all of this stuff. Me and Mark Fisher and Ian Poutzma, both of them are still around in the team. So it was more of the three of us getting together and spending a couple of quality months on embracing JDK 6, embracing JDK 5 as a kind of common version of Java. So we were moving into a Java ecosystem that was very annotation aware. Most people were on JDK 5 around that time. Groovy and Grails, a side note, but actually joined our ecosystem back then. Grails is actually it's of course, Groovy targeting web application framework with a very rich development model around it. But it's actually Spring-based internally from the early days. It still is Spring-based today, Spring Boot-based even. And of course, it uses Groovy as its implementation language. So our love for alternative JVM languages actually started back then, and we literally onboarded the Groovy and Grails development team. So the core people working on Groovy and on Grails joined our company, which in the meantime was called SpringSource back then. But it's not just Groovy and Grails. This is kind of the open source community angle of it, right? The company called SpringSource was of course trying to come up with products, right? As a company, you need to establish yourself. And this is actually an authentic slide from 10 years ago, an authentic image from that period. And you may notice a few things that are not really with us anymore. It says OSGI here. SpringSource DM kernel, which was never actually a real thing. There was just the Dynamic Modules project and what we call DM server. So my point is, we had a corporate marketing department that came up with architectural diagrams like this that had really nothing to do with the work that the engineers did as much. It just tried to draw things together. It does say Spring here. It has Tomcat. It talks about, I don't know, what kind of subsystems and about the tools. This was not just us. All the other companies around that time were trying to have kind of application development platforms. We went through that for about 2 years, but we never let go of the open source projects. So this is also an authentic graph I used in 2009. This little arrangement just is a bunch of open source projects, and that is actually closer to what we had at the time. The core framework and quite a few supporting projects, each of them a separate open source project, now basically a separate project on GitHub. So we had common names, for example, Spring Webflow for like rich server-side, stateful web user interfaces. We had the early days of Spring Integration and Spring Batch that are still with us today. We have, well, Spring Social, Spring Mobile, more like side projects. This is our commercial distribution of Tomcat. This actually continues. We still have a support contract for Tomcat, but we're not calling it SpringSource TC Server anymore. It's not a separate maintenance branch. We push everything back to the Tomcat mainline in the meantime, so it's literally just a supported version, a support arrangement for the original Apache Tomcat now. But pretty much all of what can be seen here is still with us today. There's Grails up here. There's Spring Roo. Well, that may be the exception to the rule, right? Right. Spring Roo was an attempt on our end to come up with a sort of a nicer development experience for starting a new project. Basically, the purpose is that Spring Boot serves now to some degree. Spring Roo had a different mindset behind it, though. It worked with SBJ, it worked with plenty of other stuff to kind of come up with a more concise and less code-intense getting started phase for Spring applications. It was quite popular in a certain area for several years, but never really became mainstream. So at some point, we turned it into a community project. It actually still exists. It's maintained by a different group now, because a couple of years later, we decided that we're going to have a fresh attempt at that problem, which is now called Spring Boot. But pretty much the rest of it still exists. So that is 2009. Of course, in 2009, out of this ecosystem, supporting this wider ecosystem that we can see here, we also had the next major release for the core framework. And keep in mind that the core framework at this point was already very aware and very integrated with the wider ecosystem around it. So Spring Framework 3.0 was really prepared for supporting that ecosystem. Many of its features actually came out of demand from the ecosystem. So like the spell expression language was not just used for configuration purposes. It was highly demanded by Spring Integration and the Spring Integration batch ecosystem. They wanted a nice little Spring-style expression language, and we chose to put it into the core framework so that the other projects around us could consume it from there. There was already a Spring Java config extension, a sort of research project. We also chose to make that a part of the core framework. So in Spring Framework 3.0, we really consolidated lots of feature requests from our immediate ecosystem around us, in particular from the other Spring open source projects that we already had in the wider team. Another topic of the times was REST support in Spring MVC. So, well, you could argue we kind of reinvented Spring MVC as a REST endpoint model back then. There was a lot of work going into an overhaul of Spring MVC. It started in 3.0. Most of the work actually happened in 3.1 in the end. We literally re-implemented the Spring MVC infrastructure in reasonable backwards compatible ways, so that it was not only serving for the traditional web user interfaces with HTML rendering and server-side state, but also very, very applicable to RESTful endpoints following REST endpoint design conventions, and in particular, the state management that goes with it. Endpoints that deliver JSON or XML responses oftentimes don't even have a server-side session. So Spring MVC was really opened up into the general web endpoint framework that it is today. Fortunately, that wasn't actually that radical an exercise, because Spring MVC was already a very decomposed dispatching arrangement, but it is a very significant step that we took. And of course, today in Spring Boot and also in Spring Framework itself, the REST nature of Spring MVC is actually the dominating purpose that the framework has. All right. A little side note, we constantly raised the baseline. At that time, we felt that JDK 5 is finally established enough in the ecosystem that we could require it. So the baseline basically means that the entire framework is built on JDK 5 Plus now, finally, only in 2009. It took quite a few years for JDK 5 and 6 to establish themselves properly. So that was the beginning of the modern-day Spring API, where even the interfaces and classes themselves have all the JDK 5 features, var args, generics for a start, right, across the code base, across the Spring APIs. Wasn't actually the case before. So what was the state of the art at that time? Well, it pretty much is the state of the art of today, right? So the model, the annotation-based component model for building component classes and configuration classes dates back to these late 2009 stages, Spring Framework 3.0 and in particular 3.1. So this is the model that we're still using today in the annotation-based world, the stereotype annotations, injection annotations for the constructor here, and edge transactional for triggering a declarative service, wrapping that method with a transaction begin and commit rollback, right? So in certain indications being given through additional annotations like add lazy, telling the container to have a specific life cycle for this singleton bean, starting it on demand only. So the richness of the annotation-based component model dates back to those times, mostly to Spring Framework 3.1 actually. in the way that we know it today. So this would already have worked in Spring Framework 3.1. It is still essentially what we're doing today with very minor tweaks only. So the configuration classes with factory methods, we only started to explore the potential back then. There was no Spring Boot yet, but there was this basic model, the @enable annotations. Remember the XML schemas, TX annotation driven in XML. This is kind of the replacement with a different language, right? So we spent a lot of time in this evolution phase in evolving the framework at the time. We spent a lot of time and energy on fine-tuning an annotation-based model that works on its own. So we did not try to take the XML configuration format and kind of squeeze it into annotations. We kind of left the XML configuration language the way it was and took a fresh attempt at coming up with a comprehensive annotation-based component model. So if you look at the language here, this does not sound like the XML bin definitions. TX annotation driven, @enable transaction management, they are doing the same thing, but they are using a different language to express themselves. We aimed for consistency within the annotation-based model. So that the XML model was kind of coherent and comprehensive on its own. The annotation-based model was an alternative way of consuming the Spring container services, coherent and comprehensive within itself. Some people complained that migrating XML-based bin definitions, they had to kind of switch the mindset a little, but that was the whole point, right? And of course, the annotation-based component model is with us today as kind of the reference way to use Spring in recent years. In parallel to that, in the wider ecosystem, and in particular in our corporate environment, we had a spin-off to what is now known as Pivotal. We actually were at VMware at the time, because in 2009, VMware acquired SpringSource. There was still a sort of SpringSource as a sub-company at VMware at the time, as a dedicated sort of department at VMware. And SpringSource, the wider Spring team, and quite a few other open source offerings from the EMC VMware Federation were spun off into what is now known as Pivotal. And Pivotal, of course, is where we are still at today. And Pivotal had a central product that it focused on, and that was at the time Cloud Foundry. It still is Cloud Foundry, but the offering is actually much wider than that in the meantime. So we saw the beginning of the cloud era. Cloud native applications, application system services being built for deployment to the cloud, to private clouds that you host internally, or to public clouds like Google App Engine, all the Amazon services. These were very, very important factors for the further evolution of the framework. This is actually also an authentic graphic from the times. You can't see Java and Spring here, but you can see that all of this is polyglot. Pivotal actually started to have a stronger Java Spring focus. Initially it was very polyglot, but in modern day Pivotal is actually very Java-centric again. So we took all of this inspiration with us for our next major release, Spring Framework 4. And Spring Framework 4 came in late 2013, half a year into Pivotal. Spring Framework 4 was actually a very intense effort. It was really a sort of doubling down on Spring. We didn't just want to do a major release because it was time to do it. It was more like, let's do a full revision of the framework, do a JDK 6 baseline, be ready for Java 8. Java 8 was only released in March 2014, so we actually released Spring Framework 4.0 3 months before JDK 8's general availability, with full Java 8 development support. Of course, we meant to just join the JDK 8 release, but JDK 8 was delayed by half a year, so we were actually 3 months early. The point is, we really wanted to be ready for this new world of Java 8 as early as possible, as the first framework in the industry with very comprehensive Java 8 support, literally before its actual release. It was still JDK 6.7 compatible, still is today, but the design guideline, the design mission for us was, If you're using it on Java 8 with the Java 8 compiler, then Spring Framework 4 should feel like a Java 8-based framework to you. I hope we actually accomplished that. There were several iterations afterwards, 4.1, 4.2, 4.3, very, very significant refinement releases. In retrospect, I would even argue that Spring Framework 4.1, 4.2, and 4.3 were almost a little too rich for their version label. Other projects would have called them 5.0, 6.0, 7.0, and I'm literally not joking. They were among the most feature-rich releases we ever had. We fine-tuned the annotation-based programming model. The annotation-based programming model was still the reference of the time. But even more importantly, it's the foundation for what we now know as Spring Boot. Spring Boot was released around JDK 8's GA in 2014. And Spring Boot, of course, started its 1.0 at the time and had quick iterations up until the Spring Boot 1.5 line, which is still actively maintained, built on Spring Framework 4.3. So Spring Boot, even if we're telling the core framework story here, Spring Boot is an important part of the story because it was a great influence for us. Spring Boot being more like targeting microservice environments, cloud environments, smaller deployment units, of course also a quicker kind of getting started experience, but rich support really for independent deployments, the actuator model. Spring Boot is much more than just a development time solution. It really is a rich runtime solution of its own, built on Spring Framework. And many of the common Spring Framework programming model features and configuration model features actually shine through in Spring Boot. So take configuration classes. Independently, they're kind of a nice feature, right, in the Spring component model, in the core component model. But in Spring Boot, they become an essential part of what Spring Boot does. Configuration classes, conditional configuration classes are an essential piece in Spring Boot's auto-configuration model. And Spring Boot also introduced formal dependency management, something we never actually did before. Kind of a larger bill of materials, a larger Maven POM basically, that suggests versions of third-party open source projects to be used with the Spring ecosystem, right? So you would get Spring Boot 1.5.10, and it suggests specific versions of everything from Hibernate to Jackson to whatever to be used with that particular version of Spring Boot and the underlying Spring framework. So this is also a very, very important part of Spring Boot. You get a uniform dependency arrangement that was well tested on our end. You can't deviate from the versions if you choose to do so, but there are kinds of reference versions that are known to work together very well. So that was the influences basically that led us to that step in the evolution of the framework. There were a couple of particular things we focused on. What we now know as composable annotations is very much a Spring Framework 4 idea that we continued over 4.1, 4.2, 4.3, these kind of building your own annotations, meta-annotating them, combining them into a single shortcut that expresses all of the characteristics above in one sweet, customly named annotation is something that we introduced in Spring Framework 4 in the annotation model. And in 4.3, we established a couple of what we call pre-composed annotations, like get mapping and post mapping, essentially just custom annotations, meta-annotated with @request mapping, having a sweeter, more specific design mindset. We really focused on fine-tuning the use of annotations. And there are a couple of fine lines. You know, how do you actually design annotation types with their attributes is a kind of an ongoing story that is still with us today. And there are always compromises to be made. But we were on the mission of taking the Java language as it presented itself there, Java 8 at the time, but of course still with all the annotations in there, and doing the best we can with the basic building blocks that the Java language gave us. So this is basically modern day Spring MVC style endpoints. Around the same time, so while we were working on Spring Framework 4.2 and 4.3, 4.2 actually mostly, we spent a little bit of time researching other areas. So what's happening around us in the wider JVM ecosystem. And along came the reactive manifesto. So a certain focus on reactive programming, on reactive architectures, a little bit connected to the microservice movement, trying to implement individual services with a reactive processing arrangement within the service. Personally, I'm not a great fan of manifestos. But the reactive mindset is really important here. So the qualities of service that we're trying to accomplish in a reactive architecture are really well laid out. So resiliency and responsiveness, maybe as the most important ones. Trying to optimize a web architecture towards reliable behavior under extreme conditions, under high load, under uneven load, with a mix of very quick and very long-running web requests. All of these things present challenges to a servlet-based architecture. And the reactive manifesto, the reactive mindset, is basically revisiting that problem space from a different perspective. What if we just took the underlying nature of network programming, the asynchronous nature of the way the TCP sockets work, the way that I/O streams work, taking this through the web architecture up to the web endpoints, composing a web architecture with a fully non-blocking asynchronous stream processing arrangement. We started a research project for this on our end. We were close observers of other things that were already happening, Vertex, Archive Play, and we chose to make this a part of our Spring Framework 5 effort. So we merged our research projects into the Spring Framework mainline for Spring Framework 5.0 just about 2 years ago. So in Spring Framework 5.0 we do quite a few things, and we'll get back to reactive in just a moment. But it was very much a timely release, taking inspirations from the ecosystem back into the framework once again. So Spring Framework 5 has finally a Java 8 baseline. It's Java 8 based, the entire code base, all of the APIs. Doesn't actually make that much difference to you in application development because Spring Framework 4.3 actually feels like a Java 8 based framework for application purposes in almost all areas already. But it's an important exercise for us. We can finally use all the Java 8 goodness, language and library goodness inside the framework, and we can expose it in certain API areas where we need to expose it. But more importantly, we have two themes, design themes that we follow. It's functional API design, and it's the aforementioned reactive web architectures. Those are the two most important guidelines that were on our mind when we designed Spring Framework 5. Spring Boot releases, of course, go with it, and the Spring Boot 2.0 release goes with Spring Framework 5.0.5. At the moment, or around that time, it's only about 2 months old. So we're already in the very present with this. So let me take the remaining few minutes to explore the two design themes very quickly. By functional registration, functional API design, we actually mean a sort of programmatic arrangement, but with a Java 8 design mindset. So basically, Java 8 collection streams. In Java 8, the Java util function interfaces, that sort of functional is what we mean. So in Spring Framework 5, you can do things like build an application context programmatically. That was always possible before, but you can now do it in a pretty sweet way by specifying an inline lambda expression for what we call an instance supplier. So this is essentially forgetting about annotations, forgetting about reflection mostly, revisiting the problem of how to register beans with custom creation rules. So instead of doing a configuration class, an add configuration class with an add_bean method, instead we have a programmatic call saying register a component of type bar, and here is a supplier expression for how to build a new instance of bar whenever you need it. This is part of Spring's core container model, of course. The container is in charge of actually creating those beans, managing their life cycle, managing their scope. For a session scoped bean, we would dispatch to this supplier every time we need a new instance in a new session, right? So from an API design mindset, this is really supposed to fit into a Java 8-based, functionally styled world. And of course, it may not end with a single Lambda expression. What about using another one? So here, this variant below has two inline Lambda expressions. This is the instance supplier for building a new instance. And this is what we call a bean definition customizer, which is actually, you can have any number of those. It's basically a callback that says, I'm about ready to register this bean. Would you want to set some additional characteristics, additional metadata on it? Here's your opportunity. Bean definition coming in. And in this case, we're saying, yes, lazy initialization, please, on first access to that bean. This is the equivalent of the @lazy annotation. So once again, we take an existing feature set onto a different usage model, and we're not trying to take the language that we have in the annotation-based component model and just kind of have programmatic calls for it. We are trying to revisit the purposes with a fresh and independent and independently coherent mindset here. So it's basically our third attempt for an independent usage model that is coherent within itself. So it doesn't feel like you are using a pseudo annotation model that has been translated. It's actually a fresh model on a programmatic perspective, nicely integrated with existing classes, because generic application context is a 10-year-old class, right? So we are always trying to find this balance between backwards compatibility, a new usage model, and coherency within that usage model. All right, I'll actually go in. I have a session later on today at around 2 p.m. where I will go into some more details. One additional note, in all applicable brevity, in Spring Framework 5, we also decided to embrace Kotlin. Previously, we had a strong embracement of Groovy. We keep having that. But now there's a third one among the first class languages to be used with Spring, and that is Kotlin. And I would argue that Kotlin actually is number 2, right? It's more like Java is the mainstream language, then comes Kotlin in terms of the focus, then comes Groovy at these days. And we take this quite far. So what we can see here is the same code as before, but expressed in Kotlin. And expressed in Kotlin not just because we can call Java APIs, but expressed in Kotlin against Kotlin-specific extensions. In Spring Framework 5, all across the code base, we ship Kotlin extensions. If you download Spring Context 505 jar from Maven Central, you get the standard artifact, which is perfectly usable from Java, but actually has a few Kotlin extensions inside. When you choose to use it with Kotlin, the Kotlin compiler automatically picks up those extensions, and all of a sudden, classes like generic application context, standard Spring classes in the Java codebase, have additional methods, overloaded methods, that take Kotlin K classes and Kotlin K functions. This is how we arrive at this development experience, where usage styles like these are possible. Very idiomatic, very Kotlin-embracing ways of expressing yourself, where from a Kotlin perspective, it doesn't feel like you have to do the Java dance. You get an API that is really designed for Kotlin purposes and optimized for Kotlin purposes wherever possible. So a few more details on that in my session this afternoon on the mindset and the Kotlin extension stuff. Let me conclude the Spring Framework 5 story with just a few notes on reactive. So remember the reactive manifesto? It actually turned into reactive streams as a core interaction model underneath the covers. How did we embrace it, right? It was a key question. In Spring Framework 5, we wanted to do something for reactive web stacks. We had this research project in parallel, but of course we have the existing Spring MVC on the Servlet API. how should we deal with it, right? Should we try to kind of unify the underlying API? Should we reinvent Spring MVC into a reactive model, sort of? None of those really was that great an idea in the end. In the end, we went with a clear split. In Spring Framework 5, we have Spring MVC, Spring Web MVC, on the Servlet API as the traditional servlet-based web framework that comes with Spring. And in parallel to that, we have a separate web stack called Spring Webflux, which is the reactive web API on a reactive streams and Project Reactor foundation, entirely non-blocking, and running on Netty or other containers adapted to reactive streams underneath the covers. The Servlet API is the central abstraction over here. The reactive streams API and our HTTP support around it is the central abstraction over here. Those two web stacks coexist in Spring Framework 5. This is basically the Spring Web MVC module, and this is the Spring Webflux module. They share a common Spring Web module, so they share the same annotations as far as possible. They share quite a bit of infrastructure, but they evolve independently. This is, of course, a straightforward migration path from Spring Framework 3 and 4, right? For existing Spring MVC code, just keep running it here. But if you choose to have a reactive architecture instead, because you really you believe you really benefit from a reactive architecture for certain services, certain endpoints of yours, then use the model over here instead. It's basically your choice. We provide both options in Spring Framework 5. And in terms of the programming model, this is very much aligned with modern-day Spring MVC. You actually need to look closely here to even find out that these are reactive endpoints, right? It's the same kind of code as in regular Spring and regular Spring MVC. But if you look at the signature of those endpoint methods, those endpoints don't claim the request and want to process it. Instead, they take the incoming request and build a reactive streams publisher for it. So the model is intentionally very similar to Spring MVC, but the purpose of the handler methods is different. The handler methods do not actually process the request. They return a reactive streams pipeline for processing the request. So basically rules for how to arrive at a response for this request. So the dispatcher calls those methods. Those methods just build the pipeline, immediately return, and in the runtime system then chooses to do the reactive streams interaction against those reactive streams publishers as we fully parse the incoming request and as the outgoing response is ready to be written to. Mono and Flux are effectively reactive streams publishers. Literally, they implement reactive streams, the publisher interface, but they come out of Project Reactor. They are richer expressions for a reactive streams publisher. Mono for a single element or none, and Flux for a stream of elements. So this is basically the essence of the programming model for reactive endpoints in Spring Framework 5. And alternatively, there's also a functional style, remember functional bean registration, that looks like this in standard Java. So router functions and handler functions expressing the same kind of logic, right? Totally programmatic, no annotations here. Just saying if we have a request matching this predicate coming in, here's the handler function for it, the rules for how to process the requests and how to arrive at a response. Dispatching to a repository, building a server response, taking the outcome of that repository into the body, and we're done. So this is a language, a standard Java functional design arrangement with router functions and handler functions. Works great with Java 8, with Lambda expressions, with method references. Works great in Kotlin as well. There's an equivalent Kotlin DSL for it. All right, this is basically the current end of the storyline. It's by no means an end, it's actually a new beginning. In the way we see Spring Framework 5.0, it is the beginning of a new major generation of the framework. We're currently working towards Spring Framework 5.1 to be released, to have a release candidate in July and a final release in September this year. So we see it as the beginning of this 5.x line, 5.1 in September this year, 5.2 sometime mid next year. fine-tuning what we started in 5.0. Fine-tuning the Java 8 baseline, fine-tuning the Kotlin support, fine-tuning the reactive web support, the reactive web options. And there's always new infrastructure to pick up. So we haven't really talked about JDK 8, JDK 9 and 10, the releases beyond JDK 8. But Spring Framework 5.05 works fine on 9 and 10 as well. For Spring Framework 5.1, we have a strong focus on JDK 11, the next long-term support release of the JDK, also coming in September. So we keep pushing and keep adopting the latest generation of our JVM infrastructure underneath the covers. There's also a new Reactor release. Reactor is this reactive streams library that we're using, which is actually built by a team in my immediate vicinity at Pivotal. There's a new Reactor generation, Reactor 3.2 coming that we're also picking up. There's always new infrastructure to adopt. This is why the JVM ecosystem is so great after all. There are so many moving pieces, right? It's always evolving. And Spring as a framework is evolving with it in a very timely fashion. All right, so that's everything I had for you this morning. As mentioned, I have a session in the afternoon where we will focus on some more Spring Framework 5 feature set stuff in more details. And we have a BOF session this evening at 7, I believe, 7 p.m., where we can happily discuss not only Spring stuff on its own, but in particular the wider ecosystem around it. So thanks for your attention and enjoy the conference.